I'm going to do two examples using the washer method. This is an examples video. If you need a breakdown of how to use this and how to set this up, watch my lesson video. These are basically two more examples to couple on to my lesson video. So that's where I give the full breakdown. These are the two examples that I'm going to go through. So I've got two different regions that I'm revolving around the x-axis. So let's just get into it. Okay, so I've got y equals 2 times the square root of x, y equals 2x equals 0. Okay, so let's go ahead. Oh, let me switch my color here. All right, so let's go ahead and just sketch this out. So at 0, at x equals 0, y equals 0. And then at x equals 1, y equals 2. So 2 times the square root of 1 will be 2. So here's my curve. And then I have y equals 2 right here. And I have x equals 0 right here. So here's the region that we're talking about, okay? And I am revolving this about the x-axis. So it's really helpful just to have a little sketch. So here's my x-axis. Here's one side of the shape. So then going the other way is just going to look like this. Let me try a little better. Oop. Okay. So I have this like kind of odd looking vase, cup shape, whatever. So I like having the solid because that really helps to orient me in terms of like what's the inside and the outside radius. So I need to fill in this, let's see, this formula here. So I have, this is going to be the outer radius minus the inner radius, okay? Oops, sorry, dx. Okay, so in this case, this part here, this is the inner radius, and this part here, this is the outer radius. So now I can just really fill in those curves. So let's see. So this was the outer, we just said, is the line, it's this top line here, so that's y equals 2. So that's going to be 2 squared. And then the inner radius we said is this line here. So that would be this curve, which is 2 times the square root of x. Okay, and then I still need to know what are my limits of integration. So I'm looking for the x values here. So this really goes from, let's see, this is 0, 0 to 1, 2. So these go from 0 to 1. Okay. So we're in business now. So let's see, I can go ahead and square everything. So this will be pi 0 to 1. So this ends up becoming 4 minus really just 4x, right? So 2 squared is 4. Square root of x squared is just going to be x. Okay, so no problem. So let's make a little extra space and then finish this. Okay. So now I can just integrate. Let's see, I'm going to integrate. So this will be 4x minus 4 over 2, which is just 2x squared, 0 to 1. And then I can just plug in everything. So this really just becomes 4 minus 2, all of that minus 0. So this just equals 2 pi. So there you go. And so next, so I've got y equals secant x, y equals square root of 2, and then x is bounded between negative pi over 4 and pi over 4. Okay, so once again, so I need the sketch here. So let's see. This is going to go, so go like this. Okay, so here's negative pi over 4. Here's pi over 4. So those are the values that I want to plug into secant x. So just remember, secant x is the same as 1 over cosine of x. You do really need to know your unit circle for this. So cosine of pi over 4, so that equals normally square root of 2 over 2. So secant of pi over 4 is just going to be the reciprocal of 2 over the square root of 2. And if you rationalize the denominator, you get that that just equals the square root of 2. Okay, so here's the square root of 2. So if I plug in pi over 4 and negative pi over 4, I get the same value. And so then I can just connect these like so. Okay, so there's secant, so let me clear some space. Okay, so you want to make sure you get the sketch right here. So when I wrap my head around this, so I need to go something bounded between negative pi over 4 and pi over 4, and then also bounded by this line here of this square root of 2. And so the only thing then that's bounded by all of those would be this little, this is the region. Okay, so that's what we're talking about. And then, okay, and then sorry, I know this initially said the y-axis. This is supposed to go around the x-axis, so I just changed that. Okay, so this is getting rotated around the x-axis. So what does that look like? So if here's the x-axis, so again, you just want to have like a general idea of kind of how this is going to look. It doesn't have to be like this perfect drawing, but here's your it's like it's got a big hole in it, right? So here's your solid. Okay, and so since this is revolved around the x-axis, so I always like to first just state the formula that I want to use. So everything can just be written in terms of x. So I'll go ahead and just write that down. Okay, and so now I just need to identify what's the outer radius, what's the inner radius, and that's where the solid helps. So this part here is going to be your inner, and this part here is your outer. So the outer is this line here of square root of 2, and then the inner part of the radius is this secant x. So now we can just plug everything in, and this goes from negative pi over 4 to pi over 4. So let's see, this will be square root of 2 squared minus secant x squared. Okay, so let's make some room. Okay, so if I go ahead and just simplify now, this is just going to be 2 minus secant squared x. And so when I integrate that, that's 2x minus tangent x. And so then it's going to be, let's see, that really comes out to when I plug in my limits of integration, that'll simplify to pi over 2 minus 1 minus negative pi over 2 plus 1. So let's see, what is that going to leave me with? That's going to leave me with just pi, right? Minus 2, so this ends up being pi squared minus 2 pi. Okay, cool. So if that was helpful, please consider hitting the like button or subscribing to the channel. I like offering free math help to everybody, so when you guys hit the like button or subscribe, that really keeps me going. And okay, I will catch you guys in another video.